Good morning, Robert Scribbler. It is September 21st, 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, I am going to answer a question from a commenter about the carbon cost of producing electric vehicles. One of the primary myths regarding electric vehicles is that the cost of producing an electric vehicle wipes out any benefit that comes from operating an electric vehicle from a carbon emission standpoint. This is a myth primarily promoted by fossil fuel promoting agencies like the Koch organization and other fossil fuel interests who fund climate change and clean energy misinformation promoters such as think tanks like the Heartland Institute and others. So the question is, what about the energy cost for car and battery production? It is said to be much higher than conventional cars. Could you please comment on this? I am hugely pro-electrifying our society, not least out of necessity. Also, will the next generation of batteries change the climate cost for production? So the question is a bit of a loaded one. My experience with questions like these is that they can tend to themselves promote a false impression, but I'm just going to go ahead and treat the question as if it were honest. And in all honesty, I'm looking at a number of reports here, but I'm just going to look at what is a consensus report from the Union of Concerned Scientists, and this is based on current research on electric car or electric vehicle carbon cost for production, and it's written by Rachel Nealer, who notes that I'm excited to introduce our newest analysis on electric cars entitled Cleaner Cars from Cradle to Grave, How Electric Cars Beat Gasoline Cars in Lifetime Global Warming Emissions. After years of mixed messages on whether electric vehicles really are better for the environment, we're pleased to provide one of the most comprehensive answers to date. Sneak peek, yes, they're cleaner by about 50%. So, when you include the cost of producing electric vehicles from a carbon emission standpoint, as well as the greatly reduced carbon cost of operating an electric vehicle, the overall reduction in carbon emissions is 50% or more. And I'm just going to go ahead and read this other statement. From cradle to grave, battery electric vehicles are cleaner. On average, battery electric vehicles representative of those sold today produce less than half the global warming emissions of comparable gasoline-powered vehicles, even when the higher emissions associated with BEV manufacturing are taken into consideration. Based on modeling of the two most popular BEVs available today and the regions where they are currently being sold, excess manufacturing emissions are offset within 6 to 16 months of driving. So it takes about a half year to a little bit less than a year and a half to offset the manufacturing emissions to produce an electric vehicle by reductions through to increased electric vehicle efficiency and reductions due to the ability to mate electric vehicles with clean energy like wind and solar, as well as the increasingly clean grids that are used to power electric vehicles, which result in a falling emissions curve for electric vehicles, which is not possible to achieve with fossil fuel-based internal combustion engine-based vehicles. So that's a simple explanation. I am going to dig down deeper and just explain to you how the carbon cost of producing an electric vehicle is a bit of a misnomer, and I'm just going to get into that. So first off, I'd like to show you this graph, and And this is a graph of life cycle global warming emissions from manufacturing and operating of gasoline and battery electric vehicles. And it compares a mid-size gasoline car with a mid-size 84-mile range battery electric vehicle and a full-size gasoline car such as an SUV versus a full-sized 265-mile battery electric vehicle. And when you add in the cost of manufacturing from a carbon standpoint, you get a 51% reduction in life cycle global warming emissions for battery electric vehicle and a 53% reduction in life cycle global warming emissions for full-sized vehicles on a comparison basis. Now, if you look at the vehicle manufacturing carbon cost, it's not as if there's no carbon cost to manufacture an internal combustion engine. In fact, there is a considerable cost to carbon cost to manufacturing an internal combustion engine based vehicle, because the cost, the production chain and transportation chain for materials is still linked to a fossil fuel based system. Now, there are ways to decarbonize manufacturing. I'm going to talk about that later, but when you compare mid-size and full-size gasoline-based cars, the carbon cost of producing them is not considerably less than the carbon cost of producing the frame of an electric vehicle. In fact, it's about the same. In fact, most arguments that center around a higher carbon cost for producing an electric vehicle focus on the battery, which is an additional item to manufacture, which requires its own manufacturing chain. So thus increasing the relative carbon cost. But on a life cycle global warming emissions basis, as you can see, the additional cost in carbon of producing the battery is relatively small. Going further into this analysis, however, the battery itself represents a fuel storage item on an electric vehicle. And for the internal combustion engine, the fuel storage item is gasoline. It's not oil, it's not coal, it's not wind or solar energy, it's gasoline. And gasoline itself has its own manufacturing cost. So if you look at gasoline, it costs about 2.5 pounds of carbon dioxide to produce 1 gallon of gasoline. And this adds an approximate 10% to the carbon cost of burning oil. So looking at the total cost of producing all the materials that are necessary to run an internal combustion engine vehicle in a battery plus car frame versus car frame plus gasoline, which requires refining, which is a carbon intensive process, the net cost ends up actually being about the same, maybe even a little less for an electric vehicle. So the material cost of manufacturing an electric vehicle plus a battery versus the material carbon cost of producing a gasoline-based internal combustion engine-based vehicle, including the car plus the gasoline, runs roughly equivalent. So if you're looking to reduce impacts from human-caused climate change, transitioning to electric vehicles is a big win because of the net major costs in major cost reduction in operation and the potential when electric vehicles are mated to wind and solar and 100% clean energy to have zero carbon cost in operation. Now, getting back to carbon costs in the supply chain, I just want to talk briefly about how carbon costs in the supply chain include transportation, which is reduced if transportation becomes electrified, manufacturing carbon costs, which is reduced if manufacturing is based on a clean energy system. So the potential is to go to zero. with full electrification and full renewable energy. Thank you for joining me, and I'll be